Good day, I'm Midshipman Steven Ricky A. Santiago from ES3A2, and today I will do assessment number 1. So, assessment number 1 is explaining the 2-stroke and 4-stroke engine. So, first, let's go with the 2-stroke. The operating principle is the intake begins when the piston is near the bottom dead center. So, air is admitted to the cylinder through ports in the cylinder wall, so there are no intake valves. Then, all two-stroke diesel engines require artificial aspiration to operate, and will either use a mechanically driven blower or a hybrid turbo supercharger to charge the cylinder with air. So, in the early phase of intake, the air charge is also used to force out any remaining combustion gases from preceding power stroke, a process referred to as scavenging. So, as the piston rises, the intake charge of air is compressed. So, near the top dead center, fuel is injected, resulting in combustion due to the extremely high pressure and heat. So, created by compression, which drives the piston downward. So, as the piston moves downward in the cylinder, it will reach a point where the exhaust port is open to expel high pressure combustion gases. However, the most current two-stroke diesel engines use top-mounted poppet valves and uniflowing scavenging. So, continued downward movement of the piston will be exposed the air intake ports in the cylinder wall, and the cycle will start again. So, the crankshaft is revolving clockwise and the piston is moving up the cylinder, compressing the charge of air. Because energy is being transferred into the air, its pressure and temperature increases. By the time the piston is approaching the top dead center of the cylinder, known as the TDC, the pressure is over 100 bar over and the temperature is over 500 degrees. The next, just before the top dead center, fuel is injected into the cylinder by the fuel injector. The fuel is atomized into the droplets. So because they are very small, these droplets heat up very quickly and start to burn as the piston passes over top dead center. Expanding gas from the fuel burning in the oxygen forces the piston down the cylinder, turning the crankshaft. So about 140 degrees after the top dead center of the piston uncovers a set of ports known as scavenge pots. Pressurized air enters the cylinder via these ports. So it pushes the remaining exhaust gas from the cylinder in as a process known as scavenging. The piston now goes past bottom dead center and starts moving up the cylinder, closing off the scavenger ports. So the exhaust valves then closes and compression begins to. The two-stroke crosshead engine has been favored mean propulsive power unit for the most types of the merchant vessels, as the price of oil rose. Developments in the design of these engines allow them to burn poorer residual fuels. The next, let's go to the 4-stroke cycle engine. The 4-stroke, the principles of this is called, because it is takes 4 strokes the piston complete the process needed to convert the energy into the fuel work. So let's get to first one. So induction or suction. First, the crankshaft is rotating clockwise and the piston is moving down the cylinder. So the inlet valve is open and the fresh charge of air is being drawn or pushed into the cylinder by the turbocharger during the first event or the suction stroke. The piston moves downward, pulled by the connecting rod. The lower end is moved by the crank. So the suction is easily getting getting the air, the atmospheric air. Then next is compression. So the inlet valve was closed and the charge of air is being compressed by the piston. It moves up to the cylinder. So compression, this is when the air is being compressed inside the cylinder. So the next is the power or the combustion. So just before the TDC fuel is injected into the cylinder by the fuel injector, the fuel is atomized into tiny droplets. Because they are very small, these droplets hits very quickly and start to burn as the piston passes over the TDC. The fuel ignites and burns and the first part of the working stroke, thus rising the pressure in the cylinder. So that's what you call power or combustion. Then next is exhaust. So as the piston approaches the bottom dead center, the exhaust valve starts to open as the piston now moves up to the cylinder, and the hot gases consisting of nitrogen, carbon dioxide, water vapor, and unused oxygen are expelled from the cylinder. So, exhaust is, in basic words, exhaust is when you release the air, compressed air. So I'm Steve Santiago from ES3A2. Goodbye.